Types of acids that are proton donors. There are binary acids. These have hydrogen and another element. Here are some examples of these binary acids. HCl is hydrochloric acid, HBr is hydrobromic acid, H2SE is hydroselenic acid, and H2O, you know as water, would also be called hydroxyic acid. Are you surprised? Because in the last slide on bases, H2O has lone pair of electrons that could pick up hydrogens. And so it would be a base as a proton acceptor. In this case, H2O also has hydrogens that it can donate. Naming of these acids. The format is hydro prefix followed by the name of the element followed by ic acid suffix. The hydro prefix means hydrogen containing. The next set of acids are called oxyacids. These are acids that have hydrogen, elements, and oxygen. Here are some examples of oxyacids. Notice that H2SO4, the element is sulfur, and for HNO3, the element is nitrogen. Both of these have hydrogens and oxygens. The actual arrangement is shown here, and it shows that the central atom is the element. Hydrogens are terminal atoms connected to oxygen. Oxyacids. The naming is more difficult than the binary acids, but it can be done with a reference point. The reason for this is that the number of oxygens will vary. Let's take a look at an example. For the HClO4 family, notice that there are 4 different number of oxygens. So we need a reference point, and the reference point will be ClO3-. This is a chlorate ion with an ATE ending. To name the acid, change the ATE to IC acid or ic acid. HClO3 is chloric acid. Going to the left, an increase in the number of oxygen by 1, we add a per prefix, and this would be perchloric acid. Now back to the reference point of chloric acid, a decrease in the oxygen by 1, the suffix is OUS acid. So HClO2 is chlorous acid. Another decrease by 1 going to the right, we add the prefix hypo. And so HClO is hypochlorous acid. Here is another example of naming oxyacids using sulfate as the reference point. Sulfate is SO4 2-. To name the acid, change the ATE to ic acid. This becomes H2SO4 is sulfuric acid. Notice that 2 hydrogens are required to balance the -2 charge. Going to the left, this is an increase in number of oxygen by 1. The per prefix is used, and the ic acid suffix is kept. This is H2SO5, and this is called persulfuric acid. This is an imaginary molecule as it does not exist. Now going back to the reference molecule SO4 2-, or H2SO4, which was sulfuric acid, there's a decrease in the number of oxygen by 1. Going to the right, the suffix is OUS acid. H2SO3 is sulfurous acid. Another decrease by 1, going to the right, we use the prefix hypo, and the suffix OUS acid is kept. And H2SO2 is hyposulfurous acid. Again, this is an imaginary molecule